So I was still at Stanford. So we'd been through the Kachin thing. In '84, front page of the New York Times, above the fold, breakthrough in linear programming. So it talked about Karmarkar and how he had produced a polynomial time linear programming algorithm that was 50 times faster than the simplex method. See, the problem with Kachin had been it's polynomial time, but it's not faster than the simplex method. So there was this new thing, and again, phones are ringing, is it faster, what's happening? And a problem was, because he worked at AT&T, it was stated that it was proprietary and he couldn't actually give any details about it. So it was slightly confusing because here's this algorithm, you can't tell what it is, it's 50 times faster than the simplex method and it's polynomial time.
Had it not been published at this point?
It had not been published, I don't think, fully yet. Remember, this is before the internet, before the web. Right. So Karmarkar came to visit Stanford. George Danzig invited him, and he was giving a talk. And he was in the conference room, and he was putting some equations up of what he did, but very few. And the equations that he put up reminded me of some of the equations that had been in barrier function methods, which was the topic of my PhD thesis. Certain characteristic things with 1 over the constraint squared appearing in a diagonal matrix. Yeah, the derivative of the log barrier function. Yeah. So the group talked about it. We said, this kind of looks like a barrier function. Could what Karmarkar is doing be connected with barrier function methods? So that was in '85. So the big announcement of Karmarkar was November '84. In the middle of '85, we were working on it and showed that we'd done a lot of numerical tests to show that you could implement a Newton barrier method, as we called it, and run it on a lot of linear programs, and that there was a mathematical equivalence, that you could interpret Karmarkar's method as a barrier method with a certain choice of the barrier parameter. Mm-hmm. So Karmarkar did not think of it as a barrier function. I'm not sure he
called
knew.
It the projective method.
Right. I'm not sure he knew about barrier functions because they had fallen into disfavor. Right. People thought they weren't very efficient. Mm-hmm. So that was kind of exciting.
Absolutely.
And I got to give a talk at the math programming meeting in 1985 about this equivalence. Yeah.
And there was a fifth person involved in this too, wasn't there?
John Tomlin. Right, John Tomlin. So the paper we wrote is Gill, Murray, Saunders, Tomlin, and Wright. Right, because John Tomlin had been at the systems optimization lab before and was heavily involved in the testing. So there was a funny thing that happened. I gave my talk. We're mathematicians, right? So I said, we have this result where if you choose the barrier parameter this way, the steps are the same. And afterwards, this person came running up to me and he said, this is terrible, this is terrible, this is wrong. I said, it's a theorem, it's true. And he said, I don't care, it's terrible. And I thought, well, he may not like it, but it's true. A theorem is true. So that was
that. What did he mean?
I think he meant that it was really awful to kind of diminish the importance of Karmarkar's work by showing it was equivalent to something old, which is not at all what we intended to do. It's interesting in mathematics often, especially in algorithms, I think, where something comes along later. It seems like a new idea, but if you look at it the right way, it's the same thing that was done before, possibly with a different notation and a different motivation.
So what was Karmarkar's reaction?
I don't know. I mean, I wasn't working at Bell Labs at the time.
Right. Was he there when you moved?
Yes, he was there, but he was in the math center. I was in the computer science center.
So you didn't have much interaction?
I didn't have much interaction with him. He was working on trying to get special purpose hardware built and do lots of other interesting things. He's a brilliant guy, and in no way would I ever want to take away from his achievement. Mm-hmm. But I think there was suspicion, that these barrier function people were trying to sort of muscle in on the new world of linear programming, which wasn't our intent. Mm-hmm. But it turns out, in retrospect, because AT&T took this view that it was proprietary and they couldn't tell anybody what it did, Newton's method's been around a long time. Barrier methods had been around a long time. This book by Fiacco and McCormick, which was published in '68, had been around for a long time, and all the equations were in there. Right. It's just you applied them to linear programming. Yeah. So, an interesting period in the history of linear programming.